they're known. We've talked about in the quadratic formula, but they're back again, and we need to really make sure we understand every bit of their properties. I could have done this before we did quadratic formula, but I was really excited about getting into it. So let's go back and let's recap how we do it. So normally how we do it, how I've always done it before, is I think about the biggest perfect square that goes into this number. So think about all the numbers that multiply to give me 24. We have 1 and 24, we have 2 and 12, we have 4 and 6, and technically we have 8 and 3, or 3 and 8, however, whatever order you want to look for. Now, the only one of those that's perfect square is the 4, and that's it, right? So we can rewrite 24 as square root of 4 times the square root of 6, which what's the square root of 4? 2. You can't take the square root of 6, so you leave that alone. That's how we simplify these down. And remember, negatives work the exact same way, except instead of doing normal numbers, remember we have an I, an imaginary thing we're looking at. Because again, you can't take the square root of negatives. It says in the calculator it's a non-real answer. So what we do is we break down the 162 like we normally would. I know that 81 times 2 is 162. I know the square root of 81 is 9. I can't take the square root of 2, so leave that alone. However, because of that negative in there, you don't just slap it on the outside like you would before with regular numbers. Instead, we rewrite this. We put an I in the middle, meaning that our solution is an imaginary 9 square root of 2, essentially. That's how we do those. However, that's kind of as far as we got with it. We didn't look at what happens when we have multiple things to look at. Well, that's what we're going to do. So let's say you multiply two things together. Now, we technically did this before when we broke down our square roots before. If you look right here, we kind of did that. It's kind of like we're doing it backwards. So it's almost like somebody gave us a problem, and then we kind of have to work our way backwards to work our way forwards, if that makes sense. Now, what you can do is you can simplify this down, and then work your way through. But what I do is I multiply them together first, because square roots multiply together. So 20 times 4 is, negative 4 is negative 80. And then I break down the square root like I normally would. Now you may say, why am I undoing this? I just had my thing simplified down. Well, you actually didn't. Because actually, if you broke this down into 4 and 20, that wouldn't be the biggest perfect square that goes into it. I know, because I know 16 and 5 multiply to get me 80. And 16 is the biggest perfect square that goes into 80. Not 4, but 16. Square root of 16 is 4. Can't take the square root of 5, so you leave that alone. But what did I forget? I almost forgot something. The negative, remember? That means I'm going to put an I right here. And even if you have something a little bit stranger, like in number 4, where you have some numbers on the outside and also numbers on the inside of the radical, okay, which is also called the radicand. The number inside is called the radicand. So, well, I just do it like I normally would. Well, multiply the numbers on the outside together. 3 times 2, 6, easy as heck. 7 times 8 is 56. And then, just like you would before, we're just going to simplify down the square root further, okay? 56, I remember, I had to figure this out a minute ago. 56, the number that goes into 56 is 4 and 14. Which of those is the perfect square? Well, the 4 is, so the square root of 4 is 2. You can't take the square root of 14, so you leave that alone. But I almost forgot something. I almost forgot this little 6 right here. So let's drop this down. Now, what this is not is this isn't 62 square root of 14. It's like 6 times 2 square root of 14. Well, these are two normal numbers, just like how we multiply these normal number 3 with normal number 2. This is normal 6 with normal 2. That would be 12. So that's how you simplify these things that are multiple square roots happening at one time. Okay? Hopefully that made a little bit of sense. And that's what happens when you multiply square roots together.